Machine learning. Hello world. So this will be MNIST for beginners. First, let's learn about MNIST data and softmax regression. Let's create a function that is a model for recognizing digits based on looking at every pixel in the image. Then use Tensorflow to train the model to recognize digits by having it look at thousands of examples. And let's check the model's accuracy with our test data. So basically MNIST is a data set of handwritten digits, 28 by 28 byte size, and we could represent this in Tensorflow. So basically this MNIST database is by Jan LeCun, and you could download it from the website. So it's composed of 55,000 training data, 10,000 test data, and 5,000 validation data. So basically the trained images is a tensor, 55,000 in length, and you'll have 784 dimensions, that is 28 by 28. And the labels are one hat vector, or the vector which is 0 in most dimensions and 1 in a single dimension. So softmax regressions has two steps. So first is we implement this equation for the evidence, which is we add up the evidence of our input being in a certain class. And after we add it up, we also convert the evidence into probabilities. So that completes the softmax. So for example, in this case, the blue is the probability for the positive probability. That means for 0, if the pixel is in this blue area, then it has higher probability that it's 0. When it's red, somehow it's a negative probability, so it's not less likely to be 0. Or it should be negative. This probability is from 0 to 1. But negative likelihood somehow. 1, so you have high weights for the blue ones, and again low weights for, or negative likelihood for the red ones. This one for 2, for 3, 4, 5, 6, 7, 8, and 9. So next you have the visualization. So these are neural network weights, and we could multiply them by the input. So the input is the x times the weights, the matrix, plus the bias. So then we evaluate that with the softmax function, and we come up with the likelihood for the output prediction, so whether it's 1, 0, or any other digit. So the softmax matrix multiplication can be visualized here. So this is the weights, the matrix of the weights, these are the inputs, and these are the biases, evaluated by the softmax function, and we will get the output prediction. So we could import Tensorflow as TF. So let's basically this example, let's try a CodinGame problem. So first step of the implementation is import the Tensorflow as TF. So in this case, I already have a previous code, so we could redo it. Basically this is just a similar to the tutorial of TensorFlow, which is TensorFlow MNIST. This one for beginners from the TensorFlow website, so which is also the source of these slides. So basically the import TensorFlow as TF part is here, and we're going to include our code afterwards. So first, let's come up with the placeholders for X and the W, the weights, and then the biases variables, and also the Y. So we could have the X equals to TensorFlow, that placeholder, and that placeholder will be TF float 32, and this could be any size by 784 dimension. So again, the NaN simply means that the dimension can be of any length. So for the W, we'll have the weights, TF variable, and that TF variable will initialize it at zeros, and 784 by 10. Then for the biases, we have TF variable, TensorFlow variable, and that contains zeros. Initialize it to the size 10. So those are the sizes for our variables. We also need the Y. So for the Y, we have, so Y equals TensorFlow neural network, or let's multiply mode X W, and let's add the bias. Also have the truth for the labels. So placeholder, and this float will be float 32. So again, the size could be any size, and the size of the label is 10-dimensional vector. Then we will have the cross entropy. So for the cross entropy, we're going to use the supposed to use this one, but in the experts MNIST, it is stated that it's more stable to use the chip. So cross entropy, PF reduce. This mean, and then we'll have softmax. So after that, let's have the train step. So this is the gradient descent, 0.5, you could change it anyway. Initialize and start the training. Batch 1000. Train step, and let's feed fiction. Okay. So result says that run argmax feed the dictionary validation images and join map. Okay. So let's try to run this. So these are the variables, or the variables, and then the placeholders. So the placeholder will simply take in the input, cross entropy, which is the loss function, and this is the training step. We changed the learning parameter a bit, and start the session. This is the training part, training loop, and we have here the result. So it is a stochastic training with 100 per batch instead of training it with all data at once. So let's test this one. So somehow there's a problem with What could be the problem here? Zeros. So it has something to do with line 30. And Okay. So I missed this part. And hopefully that's the only one. Error. Okay. So we have now a good accuracy, and let's submit. Okay.